Recently, I've been talking about a quantum wave theory of magic in D&D. Stick with me, I know. Basically, where we describe the spell as this Gaussian wave packet wave function. Oh, sorry, it goes back in wind. So I want to talk about what a wave function actually is in quantum mechanics. One of the big early findings that led to quantum mechanics is the fact that we can treat things like electrons and protons as both particles and waves. Now, there's two things I want to talk about. One is a really famous real-world experiment, and the other one is Schrodinger's cat. So the first one is called the Young double slit experiment. Now, here's the weird thing. If we have a wave and we pass it through some wall that has two vertical slits in it, we expect to see a pattern that looks like this. Ignore that, it should be diminishing kind of exponentially. There we go, the internet is a problem to all our solutions. And the reason for this is because of the wave interfering with itself. I won't go into huge detail, but basically you can work through the maths. It's very cool. So we do this with electrons, right? We fire it through and we get this pattern. That suggests electrons might be waves. But what's weird is if I check which of these slits the electron is going through before it goes through and does all the interference, I end up not getting this, but I end up getting a pattern of just two kind of slit shadows in the wall where the electrons are hitting. Or in other words, the electron behaves like a particle if we check which slit it's going through before the slits, but it behaves like a wave afterwards. And this is intrinsic to what a wave function is in quantum mechanics. And for reasons I won't get into, we talk about the wave function using this symbol here. So this here describes the wave. Imagine I have some particle and it can be in state 0 or state 1. It doesn't really matter what these states are for now. When I measure this wave function, it will collapse into either 0 or 1. And the probability of it being either of these states is given by this weighting in front, so it's the square of that. So in this case, it's 50-50 because 1 over root 2, we square that, we get 1 over 2. In this experiment, what we're doing, if we're measuring here, we're collapsing the wave function to decide between one of these slits at the point of the slits, and so we get this pattern. Whereas if we don't observe it there and we wait till it hits the wall, that's where we get the interference because the electron's wave function is interfering with itself. And this is where Schrodinger's cat comes in. See, Schrodinger had a problem with all this. He was like, what the fuck, guys, this is weird. Which granted, it was weird. His idea was if we had a particle, like say a radioactive decay, that would either decay or not decay with this 1 over square root 2 kind of thing, and a chain of those reactions would then kill a cat. If we put the cat in that box, does the cat itself become described by a wave function where in one state it's dead and the other it's alive, and we won't know until we observe it? Which calls into question what counts as observing. And so in the theory of magic, when we have this wave function, what you're actually observing is the damage where it randomly picks based on this amplitude here. So basically you rolling dice in D&D is simulating the collapse of a wave function according to my theory. Anyway, I hope you have a lovely day. Quantum mechanics is confusing, but I'll do my best. Okay, bye.